Hello students, how are you? I hope you are well and safe. I welcome all of you on this educational platform. In the previous classes of this chapter, we discussed so many different topics in the structure of atoms like Hund's rule, Pauli's rule, N+L rule, uh, de Broglie's hypothesis, Heisenberg's principle, Bohr's model, fundamental particles. Now, we are concluding this chapter in this class, and today we will discuss about the nodes. So what are nodes? How many type of nodes are there? What type of questions will come in examination from nodes? And about the momentum and also the concept of energy level. So these are some basic concepts that we shall discuss in today's class. So let's come and start. So now we shall discuss about the concept of energy level in this class. In this class, students, I will tell you about number one, concept of energy level. I will tell you about the concept of energy level in the single electron system and also the concept of energy level for multi-electron system. What do we mean by single electron system? When I say single electron system, I mean to say hydrogen-like species. So I'll tell you about the concept of energy level for hydrogen-like species and also for the multiple electron species. After that, in this unit, I'll tell you about the electronic configuration. We will make you understand what do we mean by electronic configuration, how do we write electronic configuration, and I'll give you some examples also. After that, I will give you some information about the nodes. What do you mean by nodes? How many type of nodes are there? What exactly is the meaning of node? That we will discuss. So here we go with the energies of orbital. An atom has orbitals, we all know this, and with the various energies. So it is obvious that different orbitals of the atom, they don't have the same energies, they have different energies. Now the energy of the electron in the subshell, in any subshell, it depends upon number one, nuclear charge. Number two, principal energy level, means in which shell it is present, and also the presence of electron in the lower energy level. Means for the energy level, you are calculating energy. The other energy levels which are lower than that level, how many electrons are present in the lower levels? Energy of any electron depends upon these three parameters. Number one, nuclear charge. Number two, principal energy level. And number three, presence of electron in the lower energy. Now coincidentally in the hydrogen atom, what is so special with the hydrogen? Hydrogen is the atom in which only one electron is there, single electron. So apparently there is no force of attraction. Exactly, I mean to say no force of repulsion between the electrons. Yes, there is a force of attraction between the nucleus and the outer electron. But this force will remain here unaffected, which means here this force will not be affected by any other electron, as this species is the single electron species having just one electron. So in this case, not only hydrogen, I said single electron species. When I say single electron species, it means hydrogen and hydrogen-like atoms. Say for example helium plus. In the helium there are two electrons, but if you remove one electron of the helium, students, it will become helium plus. What about Li plus 2? Lithium have three electrons. So what about the Li plus 2? It will have only one electron. So this is also single electron species. Now if I take the example of another species which is beryllium plus 3, although Beryllium is having 4 electrons. Yes, it does. But beryllium plus 3 is having only 1 electron. So these are the single electron species. So this says that for the single electron species, energy of the electron is determined. This is important, students. Energy of electron is determined only by the principal quantum number n. So for the single electron species, in order to judge the order of energy, we need just principal quantum number, that's it, nothing else. In the multi-electron system, the screening effect is observed. Do you know, students, what is the screening effect? The electrons which are present in the inner orbitals, they tend to repel the electrons which are present in the outer shell. So the repulsion between electrons of the inner shell to the electrons of the outer shell is called as screening effect or shielding effect. So the screening effect is the decrease in the attraction. It is decrease in the attraction between electron and the nucleus. There is always a force of attraction between electron and nucleus, but this force of attraction between electron and nucleus is decreased by repulsion of inner electron to the outer electron. Say for example, if you discuss lithium, in the lithium atom, inner electron, which one is the inner electron? That is 1s. It acts as the screen between the nucleus and the valence shell electron, which is 2s. So in case of lithium, the 2 electrons which are present in 1s subshell, they repel the electron which is present in 2s subshell. And this is how screening effect reduces the attraction of nucleus for the electron in the valence shell. Greater the screening effect, greater will be reduction in the force of nucleus. All right, this is screening effect. Now due to the screening effect, what happens? What is the consequence? As a consequence, because of the screening effect, net positive charge experienced by the electron from the nucleus decreases. Say for example, students, this is the nucleus and this is the outer electron. There is a force of attraction between nucleus and the outer electron, which is Z. Now the electrons which are present in the lower energy levels, they will repel this electron in the outer direction. This effect is called as screening effect. And because of this screening effect, the force of attraction which is experienced by the electron will be reduced. Suppose, say for example, the force of attraction between electron and nucleus is F, and the force which is because of this screening effect is F dash. Then the experienced force, what force this electron will experience? The experienced force will be F minus F dash. Is F minus F dash, because definitely nuclear charge is always much more greater than the screening effect. All right. And moreover, the screening effect is not same. It is different for the different type of orbitals. So the electron in the different subshells will definitely have different energies because of this different screening effect. Now I'll explain you. See, the closer the orbital to the nucleus, lesser will be the screening effect. Why? Closer to the nucleus, less will be the repulsion of other electrons and lower will be the energy. So this is the order of different orbitals have energy in this order. S have the lowest energy, then P, then D, and then F. But this is valid only for same shell. Principal quantum number should be same. You cannot compare energy of 3s with the energy of 4p. You cannot compare energy of 3s with the energy of 4p with this concept we just studied. This is applicable. Yes, it is applicable, but for the same shell. There must be same value of the principal quantum number. So if principal quantum number remains same, S subshell will have lowest energy, then P subshell, then D subshell, and F subshell will have the highest energy level in the same shell for the principal quantum number same. This is important here. All right. The energy of subshell in the multi-electron atom. What do you understand by the multi-electron atom? Students, multi-electron atoms are those in which more than one electrons are there. So the energy of the subshell which are present in the multi-electron atom, it depends upon the value of principal and the azimuthal quantum number. If you remember, students, I told you about the Aufbau principle in the last lecture. In the last class, I also told you about the N plus L rule. If you remember, we determine the energy of the electron in the multi-electron system with the help of N plus L. Like I told you, lower the value of N plus L, lower will be energy. So the subshells for which N plus L is lower, energy will also be lower. And definitely, if N plus L is same, then energy will be lower for the lower value of N. Students, this topic we already discussed in the previous class. So, for the hydrogen, what is special with the hydrogen? In the hydrogen, there is only one electron. If only one electron is there, there will be no screening effect. There will not be any screening effect because only one electron is there. So outer electron is not at all repelled by the inner electrons. So in this case, energy of electron is the function of principal quantum number only. So energy of electron in the hydrogen or hydrogen-like species depends only upon the value of principal quantum number n. Like you say, energy of 2s and energy of 2p are here at the same level. Here energy of 3s, 3p and 3d are at the same level. Similarly, energy of 4s, 4p, 4d and 4f are at the same level. But this is valid only for hydrogen atom. This is not valid for the multiple electron system. In the multiple electron system, you cannot determine the energy level like this. And what you have to do in that case? You have to find out the energy level with the help of N plus L rule. So for the hydrogen atom, the possible subshells are up to N is equals to 4. They are 1s, 2s. So they are 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d and 4f. Now you see, definitely second shell is having more energy than 1, but the energy of 2s and energy of 2p are same. 3 is having more energy than 2, but energy of 3s, 3p and 3d are same. Similarly, energy of fourth shell is more than third, but energy of 4s, 4p, 4d and 4f are same. So in case of hydrogen and hydrogen-like species like helium plus, Li plus 2, beryllium plus 3, in which only one electron is present, you cannot determine the energy of subshells with the help of N plus L. Here only N matters. So different orbitals of the same energy level having the same energy, they are called as degenerate orbitals. So they are degenerate orbitals. They are simply degenerate orbitals. In the previous slide, see here energy of 3s, 3p and 3d are same. So I can write it like this. Energy of 3s is equals to energy of 3p is equals to energy of 3d. I can say that they are degenerate. They are degenerate means they have same energy levels. So they are called as degenerate orbitals. Examiner sometime ask you this question, what do you mean by degenerate orbitals? Then you have to reply very simply that orbitals which have same energy are called as degenerate orbitals. Now this is the energy level for the multiple electron system. Now if the species is having more than one electron, which is multi-electron system, in this value of energy is not the function of principal quantum number only. In this case, students, in this case, energy depends upon the sum of principal quantum number and also upon the azimuthal quantum number. So when you will calculate the value of n plus L, like we studied in the 𝕆𝕆 principle, n plus L, then you can find out the energy of multi-electron system. So in the multi-electron system, energy of 2s and 2p is not same. They are not degenerate anymore. So what is the energy level? This is the energy level. For the multi-electron system, n plus L rule is applicable. Now on applying the n plus L rule, you will get the value of n plus L for different subshells. And these subshells now filled in this order. This we already discussed in detail in the last class. It is found that 3D is in lower shell than 4s. Yet 4s has the lower value of n plus L. So electron will first go into the 4s rather than 3D. Surprisingly, here 3D will be filled after filling of 4s, which is more unlikely. Because why this happens? Because of the n plus L rule. So this is the actual order of filling. This is order of filling of subshell in multi-electron species. All right. This is the order of, and also this is the increasing order of energy. When you go left to right in this order, energy increases. And obviously when energy increases, what about the stability? Stability definitely decreases. Now I'll tell you something about the electronic configuration. So what is the purpose of electronic configuration? Why do we study electronic configuration? See, students, electronic configuration is very important. In fact, very important to understand the distribution of the electron in the different orbitals. How these electrons are distributed in the different orbitals. This is called as electronic distribution. Everyone knows sodium is having 10 electrons in the outer and inner shells in total. But how these electrons are distributed? How many of them are placed in the outer shell and inner shell, which is penultimate, or the pre-penultimate shell, is determined by the electronic configuration. Students, we always write the electronic configuration in terms of NSX. Precisely it is NLX. Here this value N, it represents the principal shell. The value L represents the subshell. And this value X is the number of electron present. If I say electronic configuration is 1s2, this says what? 1 means first shell, s means s orbital, and 2 means 2 electrons are there. So whenever you see this configuration 1s2, this says that 2 electrons are present in the 1s orbital or 1s subshell, you can say. So now I'll tell you some electronic configurations. Now how do we write the electronic configuration? What are the rules? Within a shell, principal quantum number n, the filling of orbitals take place according to the increasing energy n plus L rule. So electrons always filled in the increasing order of energy, means the orbital which is lower in energy will always receive the electron first. It always receives first electron. Then next electron goes into the more energy level. So within a subshell, the lowest arrangement has the highest number of unpaired spin, which is Hund's rule. So the electronic configuration is basically governed by the 𝕆𝕆 principle, which itself includes n plus L rule, Hund's rule, and Pauli's rule. Students, please take care. Whenever we write the electronic configuration, anytime we follow these all rules: n plus L rule, Hund's rule, and Pauli's rule. How I will explain you. Now, for the sake of convenience and just to make you understand, I will write electronic configuration of few elements. The first element of this periodic table is hydrogen. So what is the electronic configuration of hydrogen is 1s1. Means only one electron is present in 1s subshell. What about helium? Electronic configuration of helium will be 1s2. Means 2 electrons are there in the 1s subshell. Now what about lithium? Lithium is having number 3 and the order of filling. What is the order of filling of subshell? What is the order of filling of subshell? Subshells are filled in this order: 1s, then 2s, then 2p, 3s, 3p, then 4s, then 3d, then 4p. Why this change in order? Why 3d is filled after 4s? Because 4s is more deeply penetrated. So energy is lower than 3d. We already discussed. So in the electronic configuration, third number helium, electronic configuration will be 1s2. Now 1s is completely filled. When 1s is completely filled, we will start filling electron in 2s. So how many electrons remaining? 1 electron. So the configuration will be 1s2, 2s1. What about the 4 number beryllium? Number 4 beryllium, electronic configuration will be 1s2 and 2s2. And with the beryllium, 2s is now completely filled. After filling 1s and 2s, now we will move on towards 2p. So for 5 number boron, electronic configuration will be 1s2, 2s2, 4 electrons, and the 5th electron will enter in 2p1. For the 6th number of carbon, electronic configuration will be 1s2, 2s2 and 2p2. For 7th number of nitrogen, it will be 1s2, 2s2 and 2p3. How many maximum electrons p can accommodate? P subshell is having 3 orbitals. Each orbital can accommodate 2 electrons. So obviously p subshell can accommodate maximum of 6 electrons. So what about the 8 number oxygen? Its electronic configuration will be 1s2, 2s2, 2p4. For the 9th number of fluorine, configuration will be 1s2, 2s2, 2p5. And for 10 number of neon, electronic configuration will be 1s2, 2s2, 2p and 6. So you can write all electronic configuration by using N+L rule, Hund's rule and Pauli's principle. If you will follow this principle, you can write down electronic configuration of any species. So this is all about the electronic configuration. Now I will tell you something about node. Students, you already know that in the modern concept, electron is considered as the function of wave, and we cannot determine the exact position of wave. So we never know where exactly electron is situated. We don't have any idea, or you can say we are not 100% sure. There is no surety of the presence of electron. We can only have an idea that probability of finding electron here is maximum, here it is minimum, or something like that. So what are the nodes? Nodes are these are those place, point, plane, axis, surface, anything where probability of finding electron. Do you remember, students, I told you about the probability of finding electron, which is psi square. So here probability of finding electron is 0. Means nodes are the places where we can guarantee that electron is not present. And for nodes, value of psi square will definitely be equal to 0 for nodes, because node is the place, point, surface where probability of finding electron is absolutely 0. There is no chance of the presence of electron. See, whenever asked question about node, he can ask you node about two ways. He might ask you a question about the radial node and about the angular node. So I want you to remember that radial node is always equal to number of radial node is equals to n minus L minus 1. Principal quantum number minus azimuthal quantum number minus 1. Where the angular node is always equal to value of L, just L. L only, nothing else. That's it. Only L. And here radial node depends upon n minus L minus 1. Now what about total node? For any species, what about the total number of nodes present in any atom? Total nodes present in atom. Total node in atom. It will be equal to the radial node plus angular node. So this will be equal to the total number of nodes. I forgot to write down number of nodes which will come before atom. So total number of nodes will be radial node plus angular node, which is n minus L minus 1 plus L. So this L will be cancelled with this one and total nodes will be n minus 1. So by using this formula, students, you can find out the number of radial nodes, number of angular nodes and number of total nodes. I hope you understood today's class, how to judge the energy of electron for the single electron system and the multi-electron system, and about the electronic configuration. And in the end of the period, we discussed something about nodes. All right. And I request all of you students that please do take care of yourself. Keep coming and keep watching. Have a good day.